Welcome everybody to April's AllWalletDevs. Unfortunately, Dan couldn't make it today to talk about the Web3 permission standard, but hopefully he'll be back next month to give us an update on that. We have Tyler, AdHot Engineer, to talk about Plume signatures and wallets. And then I'm assuming there's going to be some discussion about 3074, so I'm throwing that on the end of the agenda. If you're ready, Tyler, I'll hand it over to you, and you can talk to us about Plume signatures.
All right. So Ayush should be joining us soon, but I do have his slides, and I can start just kind of going over what Plume is. Let me figure out how to screen share here.
There we go. It's working.
Cool. All right. So essentially, Plume is Ayush Gupta's master's thesis at MIT, and he basically was trying to tackle the problem of being able to do things like zero knowledge airdrops and being able to post on boards anonymously, but still carry some kind of reputation. So essentially, this is deterministic signatures using ECDSA. So right now, when you generate some signature using ECDSA, it's non-deterministic. So like every time you sign a message, the actual signature is different. And what Plume allows is you to have some consistency. So with that, unique, deterministic, and you can verify without secret. So so you can use this to basically claim an airdrop on a different wallet and to be able to only claim it once. So right now, the only way to do that is by generating a proof that takes quite a long time to generate client side. All right, Ayush is here. Ayush, do you want to present?
Yeah, I can go from there. That was a good start.
Cool.
Feel free to keep the slides up. Cool.
Cool.
Yeah, and so I think the big thing here is that you can get like the last property being non-interactive. So it's kind of like if you have if you're trying to do ZK voting with semaphore or like a tornado cache style system, the problem is then your like an anonymity set is only people who have signed up. Versus here you can say, oh, my anonymity set is like all Ethereum wallets, and none of them have to opt in. You can just make the anonymity set as large as you want. Stateless, redeem only once signatures. Yeah, it's kind of like that in the sense that each public key can only sign a certain message once, and there's no way for them to fake another signature. Versus with something like deterministic ECDSA, a user could just go in, change their random seed, and you would never know.
Okay, so does that mean so the same message, do you have like a seed or something that you can pass in to change it if you want, or is it always? Yeah. Okay, that's really cool. Yeah, that's sick.
That is an argument. Yep, so it's pretty cool. So I guess one thing to understand the specific construction is if you want to go to the next slide, there's like a bunch of ideas. Oh, no, up there, 6. Yeah. Okay, so deterministic ECDSA is something we already mentioned. Like if you want to verify it was actually done deterministically, you have to pass in the secret key to verify the randomness was done correctly. So that wouldn't work because just for the ledger, you can't even like export the secret key. You can try something like, imagine your signature was like hash of message comma public key. The problem with that being like your signature is that it doesn't really satisfy the properties of the signature, 1, and 2, like the main issue is that if you this is supposed to be anonymous, right? You're not supposed to know who did it. But what I could do is I could just iterate through all 400 million public keys that have ever like sent a transaction on Ethereum, and then I could just brute force who this was. Okay, so hash of message comma secret key. What if this was your signature? The problem with this is that then you would need like Oracle access to the secret key to be able to verify this within a ZK proof. And so again, you have to export the secret key to a ZK proving library, and hardware wallets aren't able to run ZK proof, so you can't like do it within the enclave on the hardware wallet. So that's going to work. And the last one that this actually uses is hash of message comma public key to the power of secret key. So you have some information about the secret key, so you need that to be able to reverse engineer who it is, but you can actually verify this without the secret key with this like weird trick. So yeah, if you go to the next slide, 8, I think. Yeah, so basically, like the high level idea is you want some deterministic function of the user's secret key that can be verified with only their public key that keeps them anonymous within the chosen anonymity set. You can solve this by deploying a new kind of deterministic signature on existing Ethereum public-private key pairs. And so if you go to the next slide, we have a bunch of like math to explain why this hash of message comma public key to the power of secret key can be verified without the secret key. And the main like trick here is that you have the like G to the power of secret key, aka the public key. And so if you can prove the discrete log of the public key is the same as the discrete log of this nullifier, then you can prove that you in fact like signed this message. And so the kind of trick here is because we have like the public key available to us within the ZK proof, we can actually verify this without the secret key, which is pretty dope. The one interesting thing here is that you'll notice there's like this R term kind of floating around. The randomness is not part of the outputted nullifier / signature, but the randomness is used to generate a new set of like verifying values each time, you could say. The idea is if somebody can generate these values such that that discrete log proof checks out, then they must, like this must have been a real nullifier from that public key. And you can do this all within a ZK proof. The randomness just needs to be generated randomly inside like that enclave. Sweet. And then there's like some cool stuff with like quantum resistance. If you go to the next one, where it's kind of like something like semaphore has like a hash in it. And so the idea is that any deterministic signature, it's very difficult to make it quantum proof because specifically if somebody had the secret key of some Ethereum account, then they would be able to like reverse engineer what this value was. And so actually like one cool way to do plumes, you can do plumes directly on the seed phrase or like a different hash of the seed phrase. And that's interesting because then you can basically say, oh, like you can prove all the way down to the seed phrase and then prove all the way back up, giving it quantum secrecy as well. So there's like some weird modifications you can make to make this quantum proof that's like not that hard to make. And then next slide. Yeah, just some more stuff with quantum proofness and why you would have to make that change to make it quantum proof. And then maybe next one. Yeah, again, more quantum stuff. And then the last slide is just like links to all the different like explanations. So we have like a paper that proves like all the uniqueness, all of the like signature properties. The blog post like blog.ahg.com/plume that explains this more in detail. And then we had like a MetaMask snap, but MetaMask snap disabled signature access. So theoretically, they're improving this sometime. I'm not quite sure the status on that, but it's not possible to do in a snap anymore. So a snap like is broken. We had a PR to MetaMask core, but it seemed like for some reason MetaMask was not interested in incorporating it, which was odd. So if anybody has any ideas for MetaMask core, let us know. That's like just an outstanding PR. Yeah, we have a bunch of PRs to all these wallets. We have a PR to Tahoe wallet, Ravi wallet. There's PRs to 2 more wallets actually. We have one for Ledger, so that like compiles and runs, put it in the official Ledger store. Yeah, MetaMask is here. Cool. Yeah, we should chat about that. And then we're thinking of also putting it into Phantom and other wallets. Why is the snap broken? Basically, there's this thing called CoinType60, which is basically allows you to access a user's like Ethereum public-private key pair, and that is just got blocked in Snap one day. And this sort of makes sense because then Snaps can no longer access your private key, but it also means that you can't generate new signature algorithms with existing key pairs. And so there's like some workarounds here, which is like if you allowed 2 APIs to the secret key. So for instance, you could output like this nullifier function. So like you could say, oh, if a user passes in a message, you could take the hash of it and exponentiate to the secret key and then output. That would keep the secret key private, but then still allow you to like make enough query accesses to make Plume. And then you could also do a thing like blind output of secret key. So you output like R plus like secret key times some like, I don't know, like random, like, I don't know, like we call it C. So like you can make the API so that a user can query this with some C, and then you output this like R plus SK times C. MetaMask improvement proposal. Cool. Yeah, we can work together to. It would be cool if maybe like make a chat or something, and I could send like a MetaMask improvement proposal draft or something. We could jam on that and then post it. That would be cool. We had a chat with some MetaMask folks If you guys wanted to be added to that, if you put your Telegram in the chat, we can like make that happen. And then the last thing is we had an ERC open, ERC 7524, and that one, I think Sam actually left a bunch of comments on it. We addressed all of them, and now we're just waiting for that one to be merged. If you command F ERC in this README, you should see it. Yeah, this one. Yeah, maybe the official ERC or something.
Yeah, that's just waiting on me to get back to it. Sorry.
Oh no, you're good. Sorry, yeah, the link might be broken. If you just Google Plume ERC. Okay, just Google Plume ERC or like ERC 7524. Yeah, exactly. It's this one. Yeah, so this one, like, I mean, Sam and I discussed this in the thread, but it like auto closes. But at the top of that thread, it links to the new like /242. I think is the new. Yeah, this one, or at the bottom of the thread. Yeah, move to 242. So I just reposted it with all of Sam's comments here. But yeah, if there's anything we can do to get this like merged faster, I don't know if you have like another round of comments or anything you want to do.
Just remind, so 242. Yeah, I'll try to take a look at that. 242. It's just like I generally review an order, and since it got closed and reopened, it got pushed further down. So sorry about that. I'll make sure to get to it as soon as I can.
No, that's good. Yeah, I mean, yeah, I'm also down to reopen 37, and we can just close this one and then put it back there, and then that way it can be in the correct place in the priority queue. But yeah, if you can handle it, especially that would be.
No, I'll just take a look at this one like after this call. Not a problem. No, that's really exciting. So what kind of use cases does this enable? Like, where do you see people using this most?
Yeah, there's a couple of things. One is like stealth drop. So basically, we did this like anonymous airdrop thing with like normal ECDSA keys, but the problem with that again is that anybody can claim any number of times. And I think ACCNZ did one with semaphore, but the problem with that is that then all users need to opt in before you start. And so when some protocol tried to actually do a ZK airdrop, they had this problem with like basically users had to like all sign up for the airdrop in phase 1, and then they did the airdrop in like phase 2, and this meant that the anonymity set was only the people who like signed up in phase 1. It was like there was like a big mess. So yeah, I think one thing is like ZK airdrops, like especially for like ZK protocols, like if they want to do that, I think that's like particularly nice. That's the first one. The second one is like message board stuff. So you kind of need this a lot for message board moderation. So let's say you want like an anonymous message board where someone proves, oh, I own this NFT, and so now I'm going to enter this message board. I'm like now Zao was experimenting with this. Some other folks are experimenting with this. The problem is you can't ban people, right? Like if somebody is like, I don't know, being abusive or something, there's no way to say, oh, like I'm going to ban you. So you just come back with a new ECSA key. But if people sign up with their plume, then you can say, oh, we're going to ban this person from posting in this thread, for instance, because maybe the plume message is like that thread ID. And so now that user, you can anonymously ban users, which is like kind of cool for like whatever.
So they'd be able to prove that they own an NFT, and you'd be able to say they can only generate one proof. So when you ban that proof, they can no longer access it. That's sick.
Yeah, exactly. So it's pretty cool. And you don't know which NFT you're banning. You're banning the person who said that like bad thing or whatever. Yeah, so it's like it's kind of this very nice like this way to add like unique anonymity to any like Ethereum key.
Cool. I don't want to hold questions. Oh, go ahead.
Go ahead. No, go ahead.
Oh, I have more questions, so you go ahead.
Yeah. Yeah, I was gonna say the last interesting. I mean, there's a bunch of other use cases, but the last interesting use case is like you need this for proof of solvency. A bunch of people were trying to say, oh, like exchanges can come in and prove they have some assets in some wallets. The problem is two exchanges could just say they have the same wallet. Right? They could say, oh, like we're gonna collude and like all of our stuff isn't liquid, but if we share this wallet and we both make a proof of it, then we could technically prove a proof of solvency anonymously and share the same wallet. So you wouldn't actually have the funds that you claim you have. But if you have to publish a plume proof for every like wallet you're proving you have access to, then like exchanges can't share the same wallets, and so you end up like anonymous proof of solvency would actually then be possible, and it's not currently possible.
That's great. Does anybody else have any questions? Otherwise, I have two more. Okay, so how secure is this?
Yeah, how secure is this? So we have the paper. If you go to like iug.com/thesis, we wrote basically like a cryptographic paper where we prove all the like Oracle security of each thing. We had the core library audited once, and we'll probably do a second audit before we release like on mainnet for people, just so that people have more confidence that like what is reflected in the repository is actually reflected in the like paper. There's also, I guess, Mina and Aztec both had implementations of it. I think Mina's, they use Poseidon instead of Shard86, but that's still fine. That just makes the proof a little bit faster. Yeah, it's pretty secure. I mean, if there's any like reservation people have for the implementations, we have docs also for everything. People can go into the npm repo and look at like the different services that are exposed. But yeah, I think as long as the audit confirms that the implementation corresponds to like the properties in the paper, then everything should be secure. If people want to like make sure, yeah, this one, if people want to make sure things are, it's also on ePrint IACR. There's like a preprint there if people want to look at it. But basically, if people want to like verify the security, I'm happy to do like, I don't know, coordinate on like a specific audit for the implementation, a specific wallet as well or something. But as long as you correspond to the API that we expose, it should be totally secure.
Great. I think that answers my question. And the last one is, we have a bunch of wallet developers here. What would you like to ask them for? What, if you can get them to do something, what is it you want them to do?
Yeah, so the two things for wallet developers, I guess MetaMask we already talked about it. Like, figure out, either make those two APIs public in snaps, like the things that give you like query access on parts of the secret key, but not secret key directly, or help us integrate it into core. We have this PR to core that's just been open for a while. We don't want to allow arbitrary signing. Why can't another coin type work? So the problem is you want to often make, so coin type 60 allows you to prove you have some Ethereum key with some properties. And so you could say, for instance, hey, my Ethereum key that owns this NFT is also going to generate this plume signature. And this allows you to link this like unique anonymity to existing properties that your Ethereum key has done some action in the past. And so the problem is, if you don't use coin type 60, then you would have to make the proof on like some other non-Ethereum key, and then that's kind of useless, because then you lose all the like properties of your Ethereum key you want to make the proof about. Yeah, that's a good question. Why do we need coin type 60? Does that kind of make sense? Hopefully. Yeah, and I guess on MetaMask wallet, helping us like basically just like pass the PR. So like if you are running, I don't know, like Coinbase wallet or whatever, like we can make a PR into the wallet and we can say, hey, like, you know, this adds plume signatures to wallets, and then just helping us like figure out who are the right people to talk to merge this in, or if we have the word about security, to do a second security audit before we merge it in, or whatever it is. That would be super helpful. Also letting us know if you're not one of the wallets you've already made a PR to, like if you want this property in it, and then we can put you guys in, and that'll help. Also, I think it'll help like advance the wallet to like be other ZK apps. Like if people want to do ZK airdrops or interact with ZK message boards, this kind of primitive will be critical for those wallets. Yep, and those are all of the actionables.
Awesome. Thank you so much. If you've been doing implementations for wallets, you should come take a look at Wallet Test Framework. We'd love to have tests for Plume in there if you want to play around with it. But yeah, thanks for presenting. That's awesome. That's a great presentation.
Yeah, I'm glad people liked it. Yeah, feel free to drop the link to that test thing in the chat, and I can go check it out.
Yeah, so I think that's pretty much it for scheduled stuff. I'll open up the floor to 3074 discussion, since that's been pretty hot lately. If anybody has any questions, things they want to talk about, yeah, thanks for presenting. Yeah, anybody want to chat about 3074? I guess. Okay, let me start with a more specific question then. Out of the wallets that are represented here, I think there's MetaMask, Coinbase. I don't know if there's anybody else. Will you be supporting 3074 day one, or are you going to be building support later? What are your plans with that? Let's start with MetaMask.
Can you hear me?
Yep, we can hear you now.
Okay, sorry. Yeah, so I believe we are currently sketching out. I'm not directly involved with this, but just to recap, the question is: Are we planning to support 3074 out of the gate, like migrate users, help them migrate?
Allow them to make some kind of signature for 3074. Yeah.
Yeah. So as I said, I'm not directly keyed into these questions, but the yes, the plan for sure is to do so, and we're kind of like sketching around migration paths to allow users to do so, and sort of then transition the wallet UX accordingly.
Okay, cool. It's good to hear.
Yeah.
What about Coinbase? Do you know what your plans are for 3074?
Nothing concrete yet. I can't really speak through this new. I know that we're interested in using 3074 as a migration path for our EOA users or smart wallet users, and I think we're also like aware of kind of the security risk of 3074, and probably will build some like scanning to prevent any loss of funds, and kind of like in our transaction simulation. That's kind of like the extent of what we've kind of like spitballed so far, but I'm sure as it becomes more real, we'll have a more concrete plan.
Great. Yeah, I just want to make sure everybody's thinking about it early. So yeah, thanks. That's it, I think, for scheduled discussion. Oh, testnet's up. Not yet. We are planning on setting one up. I think Reth is working on one. That'll probably be the soonest. But yeah, nothing official yet. And so you're planning on removing ETH sign. That's awesome because that's a terrifying function. Yeah, great. Thanks, guys. Great. Yeah, then we can call it early. And thanks everybody for coming out. That was a great presentation, and we'll see you all next month.